Okay, now the next one on our booklet here, if we turn the page, is predicting precipitation reactions. Now for precipitation reactions, you're going to need your solubility table. And the solubility table tells us how likely it is that something is going to form a solid within that solution, or what we call a precipitate. Now when you look at these sheets, this sheet here, soluble means we won't see it. It will be in the liquid. It will be dissolved. Low solubility means that it's insoluble for our purposes. So it'll be a solid. It'll form a precipitate. So how we read this? If we look at nitrates, which is a really common one we work with, it says that all are soluble. So when we have our anion, nitrate, the negative, all of the positive ions are going to be soluble. When we look at our hydroxides, which is one of our anions from our common anion sheet, it'll tell us here that when hydroxide forms with or bonds with lithium, sodium, potassium, and so on, that is going to be soluble. So it's going to be invisible in the solution when hydroxide bonds to one of these. Now when hydroxide bonds to something outside of there, such as calcium, for example, calcium is not listed in that list there. So we come down to the all others for calcium. It's low solubility, meaning it's going to be insoluble, or it's going to form a solid or precipitate when we mix hydroxide with calcium, or we mix hydroxide with any of the things that aren't listed in this top list there. Let's look at carbonates, phosphates, and sulfites. So these all work in a similar sort of way. Again, if we have lithium, sodium, potassium, and so on, they are soluble, they'll be invisible, they'll be within the solution, they'll be staying liquid. But anything else that's not listed there, such as, for example, barium, is not listed for the carbonates, phosphates, or sulfites. So if barium bonds here, it's going to fall in the all others. It's going to be low solubility, which means it's going to be insoluble, which means it will form a solid or a precipitate. So when we're looking at our precipitation reactions here, we are essentially trying to deduce or guess whether, in this case, lead chloride or potassium nitrate, based on this table here, are likely to form a solid. So let's look at that first one there, which is, so this is precipitation. So the first one on your predicting precipitation is lead nitrate and potassium chloride. So it's already balanced for us on this first sheet as well, which is handy. PB for lead, NO3, 2 plus 2 KCl goes to PbCl2 and 2 KNO3. So lead nitrate, nitrate being one of our common anions there, lead nitrate plus potassium chloride, I forgot the L, potassium chloride turns into lead chloride and potassium nitrate. So these are the ones that we need to work out whether they are soluble or insoluble. So let's look here at the chloride, which is going to be our anion. So if we look down here, all the ions, right down the bottom here, chlorides. Now what it tells us is when chloride bonds with silver, lead, mercury or copper, it has low solubility, meaning that there's likely to be a precipitate. It's going to be insoluble or a solid. It's not going to dissolve in the solution. So that would mean that this one is I, or insoluble, whereas all others are going to be soluble in that case. Now, if we look at potassium nitrate, nitrates, all of them are soluble. So we know that in this case, our nitrate is going to be soluble. So when it comes back to the question here, was the precipitate formed? The answer is yes. And the chemical name of the insoluble, the precipitate, is lead chloride. Lead chloride. There you go. All right, now let's try this next one, and then I'll leave you to finish the others on your own. So B tells us sodium hydroxide plus aluminium sulfate produces sodium sulfate and aluminium hydroxide. Now, these 6 here, 3, 2 there, tells us that this equation has already been balanced for us. So let's write that down now. So we have 6 NaOH plus Al2 SO4 3 goes 2 3 Na2 SO4 and 2 AlOH3. Okay, so this equation is telling us that sodium hydroxide plus aluminium sulfate produces, the reactant produces sodium sulfate and aluminium hydroxide. Let's bring back in our solubility table, and this time we're going to start with the sulfates. So sulfates are here, SO4, and what it tells us, the low solubility ones, Ca, Sr, Ba, Pb, Ra and Ag, they're all low solubility. Now sodium, Na, is not in that list, so it falls in the all others, which are soluble. So we know that this one is going to be soluble. Now if we look at our hydroxides here, and we're looking for aluminium hydroxide. So we're looking for the Al in this list here. Al is not on that list, so these are the ones that are soluble. Aluminium will fall into the all others, which are low solubility. So we know that aluminium hydroxide, aluminium falls in here, has low solubility, so it will be insoluble, or it will form a precipitate. So if we come back to our question, precipitate formed, the answer is yes. And the name is aluminium hydroxide. Aluminium hydroxide. And that's how you'll then answer the rest of these there with your solubility table.